All right. Test recording. Hopefully this is recording the screen. I don't know. I hope so. Okay, so here we go. Boom. So pre-lab, I've done all this. I got .NET installed. I've cloned the Git repository. If we don't want to clone it, we can download it. I've done .NET run. These links work. What I want to walk through is what these links are doing. Now I'm looking here and you'll notice because my screen's there, but I'm recording on the big screen in my office. Like, I don't know, it's going to look weird. So let me get to here. All right. So I am going to do .NET run. Now this will fire up my server. All of this stuff, this yellow, who cares? These are just warnings. I could tell it to ignore warnings, but I never really think of that. So it's running. To stop it, I would type stop. Let's pop on over here. So now, if I go to this link, localhost, I'm just going to copy this, 8080. You can see example web page. Now, what is that doing? Well, I'm going to go ahead and stop this server here. If you look in this files folder, I'm going to do ls, you can see there's this index.html. Let's code file/index.html. What does this look like? This is an example web page. Look at it. It's HTML, whatever this is, example, big header for example web page. Now, if we look here, that's exactly what we're getting. That's what we're getting. If we just say localhost 8080 slash, you can't see the slash right now, but there was one there. That's just looking, get me whatever's there. It's looking around for an index.html in this files folder, right? In that folder files. Now, other things we can do if we run the server, and I'm actually going to do a trick here. I'm going to open up a second terminal in Simple Server, not that one, this one. So now I have, and how do I do this? Does this let me have, no, how do I list my terminals? Seriously though, oh, here they are. This is weird, right? Don't you think it would tell me more about it than just that? Maybe make this, oh, there we go. Now we're talking. Okay, I've got two terminals, Simple Server and Simple Server. So what I'm going to do is I'm going to do .NET run. To run it in one of them, it's going to go blah, 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 blah. Life is good. Now, if I go over to this one, which is in the same location, I can look at stuff. So let's go into files and let's look at everything. And there's actually a campus map PDF. Well, that's interesting. What's that all about? Well, watch this. Now, if we go back to our browser and we go here and we got to spell it right, campusmap.pdf. Boom. It's serving up the campus map. Oh, this is my special. Yeah, that's interesting. This is for whenever I teach in the compass room. I have to send out a map of where the compass room is because, it's not obvious when people are like, your class is in the compass room, what on earth that means. So I have to send out a map. This is my own special map of where the compass room is. I just wanted to pick any PDF. So one of the questions is what's going on? How are we getting this index.html? How does it know to give us this campus map? What's going on with this code? Well, that is something that we can look into. So if I come back over here, I'm going to go back a directory. I want to see, well, let's look at program and just see what that does first. So program, this special program file doesn't need to have public class main, public static void main in it or whatever. It'll just take whatever's in here and shove it into a main function, and then it will figure it all out. This is a special .NET thing. It's not a C# thing. .NET figures all this out for you. You basically don't need to have a class and a main to contain everything for program.cs. Everything else you would. Anyway, so I'm defining two functions, test JSON. Why do I have this in here? Tip for reading JSON. We're not going to do that right now. We'll do that later. Test server. What does this do? Well, we're creating an instance of simple HTTP server, and we're telling it, I want you to serve files out of the files folder. Remember, that's this files folder that has index.html and campus map. And we're saying port 8080. Great. Now I've got this while true. print out server started. You can follow in commands, blah, blah, blah. We're going to read a command. And if the command is stop, we'll stop the server and then break this loop. Otherwise, we'll just come back up here and I guess yeah, well, this is just what stops the server. So it says like, hey, you can try why did I put this inside the loop? Shouldn't I put this before the loop? Huh. Well, that's one of the things we'll fix. This right line should be before the loop. But anyway, it's reading a command. The command here is, just whatever people type in and hit enter. And then if it's stop, we're going to tell the server to stop. What server here? Well, it's this instance. So this constructor has to do a whole lot of work to create and start the server. And it does. We'll look at that next. That's simple HTTP server. That's in simple server. So let's look at that next. Okay. So let's find it. Nope. There we go. Simple HTTP server. So it's got some private variables. That's a dictionary. This is a array. This is another dictionary that's very long. Here's some other instance variables. We have a server thread. We have root directory. We have an HTTP listener. We've got, this is, believe it or not, a get set thingamajig. This is the data variable for port. Okay, that's great. Simple HTTP server constructor. We have a path and a port. Good. This calls initialize with path and port. So now I've got to look at initialize. Okay, great. Where is that? Where are you, initialize? That's process. Where's initialize? Come on. Here it is. Initialize. Okay. So given that path, that files folder, we're setting that to the root directory. Okay, great. We're setting the port to the port. These are the instance variables. For whatever reason, the code the starter code I use for this, which is linked up at the top, use this convention of like prefixing instance variables with an underscore. So I'm just doing that. But then they're not consistent about, they're doing this dot whatever, but then they're not doing this dot whatever here. I don't really know why. I don't know, whatever. We're creating a new thread with the listen method. And then we're starting that thread. So what this is doing, this initialize, which is called by the constructor, we're setting root directory to this path, which is files. We're setting port to whatever port number, which is 8080. Then we're creating this server thread out of this .listen. Listen is actually a method. This is something you could never do in Java, pass a method as a parameter to a function, but you can do that in C#. So we're saying create a new thread out of the listen method and then start that thread. So in order to figure out what the server is going to do, we have to go look at that listen method. So let's do that next. I wonder if I can click on it and then navigate to it. So if I right click on this, can I say open, find all references, find all implementations, go to definition? I can. That's awesome. Okay, so here we are. So now we're creating this listener, which is an HTTP listener. We're configuring it. This is basically saying like, listen on localhost to whatever port number we were given, which is 8080. And then start this listener. Now this listener is an HTTP listener. It's going to listen on a certain port for HTTP requests. That's what this method is saying to do, but we wrap this method with a thread. So this method's running in a separate thread. That's why we can still type in commands like stop, and the server's not like stuck waiting for that. So the server's running in one thread, and main, which lets us type in commands, is running in another thread. Okay, what is this loop doing? While not done, this again is an instance variable, which is initialized. If we look up wherever it is here to false, right? It's initialized to false. Okay, great. Where'd listen go? There we go. So while we're not done, print waiting for connection, and then try to read a connection. So take that listener thread, get context. This returns an HTTP listener context, which is like got information about the request. What did they get? What path did they want? What port was it on? Were there request parameters? I don't know, a whole bunch of stuff. So we're going to grab all of that and then send it off to this process context method. Great. And then we've wrapped this with a try catch block. So we're catching any exceptions that happen and printing them out. Now, you generally don't want to randomly catch exception, like the top level of exception, because then any exception could happen. But the reason we're doing that is so that if an exception happens, a null pointer exception or something, it doesn't crash this method, because there's only one of these running. There's only one thread running, right? And so if we get an exception, there's some error, or they ask for some path that doesn't exist, or there's some slight bug in our code, so like some particular request doesn't work. Well, we'd like for that request to fail, but we don't want to like bring down the only thread listening for connections on the server and kill the whole server just because like one request failed. There's going to be errors. Requests might fail all the time. Not all the time, but occasionally, right? That doesn't mean we should take the whole server down. There might be 99% of the server functionality works and 1% doesn't work. Well, no business wants to take the whole server down because 1% of it doesn't work, if that 1% of it isn't like a security vulnerability or mission critical or something. Pound in the Diet Coke. Okay, so that's why this try catch block is here. So all the work is getting done in this process method, which calls us context. Well, let's do go to definition. Bam. So we got this HTTP listener context. Where did this come from? The HTTP listener, which is a built-in class in C#, which is listening on port 8080. It got a connection, it got the context from it, and it passed it off to this method. This is how we're listening for connections. What's this method doing? Well, it's getting the file name, which is the context.request.url.absolute path. So this is like slash foo or slash books or whatever it is in the URL, right? And in fact, if we go down here and look at this, we can see waiting for campusmap.pdf is the path. So that's this that's printing, right? So here we went to localhost 8080/campusmap and it said, what's the path? It's campus map, right? That's what we're seeing here. So we're not seeing the full path files because we're saying like web server, serve things out of this directory called files. What that means is this localhost 8080, blah, 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 whatever. This is to get to the files folder. And then this is like whatever's in the files folder. So campus map PDF. Okay. So that's printing out, what's the path? Oh, and this substring here is to get rid of the slash. Because if we were to print this without the substring, we would be getting /campus map. We don't want that leading slash. We don't care about that. So we're just going to substring it away. That's what we're doing here. Now, this is for like little servlets. I'm calling them servlets. No C# person would ever call them servlets. They have some ASP.NET name for it or something. I don't know. I'm using servlets because I learned Java servlets in like 2002 or something like that. So I have a whole map of these, a dictionary of like paths like foo and books that map to particular functions. We're not going to talk about that yet. But if we find one of these, if some servlet contains the file name, in other words, like foo or something like that, then instead of looking in files for some physical file with that name, we're going to like launch this program with its own process request and then return because that we've now processed it. But if we don't see something, in other words, we don't find our file name in there, then we go down to here. So now if our file name is null or empty, meaning, we went for like blah 8080/, we didn't have anything after it, that's looking for an empty path. So if it's null or empty, look at this for each index file and index files. Well, what's index file? Well, let me think if I can I do function F12? Well, where's my function key? I don't have a function. That's weird that I don't have that on this keyboard. Let me try this. Nope. Nope, that's not what I wanted. Control F12? I know it's F12. Go to definition is F12. But I want to know like how I make the F12 in this keyboard do it. Maybe I yell at it. F12. Nope. That didn't. Usually there's a function button on a Mac keyboard, but this is literally a Mac keyboard and I don't know how to get to the F. Is it this? No, that's the on-off button. I don't know. I got nothing, so I'm just going to right click. Go to definition of index files. So you remember this was this array of index.html, index.html, and default HTML, default HTML. These are like possible names. If you get to an empty folder and there's somebody's like requested a folder, but they didn't request a specific file in the folder, these are the possible defaults to look for, like default HTML files to look for. This isn't necessary to have, but it's a useful feature for servers to have. A lot of times when you go to a website, you go to like www.knox.edu/ and you just hit enter, and it takes you to Knox edu. You don't have to say Knox edu/ index.html to get the landing page for Knox College, right? You wouldn't need to do that. You would just go to Knox edu, enter, right? You wouldn't list anything there. And then our web server has like a list of defaults, and it's going to be like, oh, well, they didn't ask for something. You know what? We're going to pick index.html, which is our default landing page, and we're going to show that to them, right? This is a useful thing for web servers to do. So this is where we're encoding what those possible names could be, right? So if we get to a folder, we didn't ask for something specific in the folder. In this case, it's just the root level, the files folder. We're going to look in there for something called index.html or default HTML or whatever. Now, if we come over here, and we, come on now, ls into that files folder, what do we see? Well, we see index.html. So even though we don't specifically ask for it, this is what's figuring out to go find it. Now, let me see if I can get go to definition, go to implementations, find all references. Ooh, that looks good. This was nice. And then how do I, good. And then how do I make this go away? No, just go away. Go, no. I don't want this anymore. Great. Love it. So that takes us back to here. Anyway, so that's what's going on. If we asked for, our file name was null, we didn't ask for a specific file, then look through our potential default index file names. And if you find one, then path combined with root directory, in other words, go into files, whatever, and then break. So now we've like made the correct file name and then combine it with the root directory and whatever else, and then serve it up. So if the file exists, we're going to serve it up. What does it look like to serve a file for the web server? Well, funny you should ask, because I will tell you, or at least try to. So we're going to get this input stream, which is a file input stream. Basically, we're connecting an input stream to this file, which we now know exists. So index.html, whatever it is. And then we need to build a response. So this context, remember, that's the HTTP listener context. It has a response. The response is both like we're setting configuration of that response, like what type is it, how long is it, add these different random headers, date, last modified, whatever, but then also what data is going to be in the response. So these are the HTTP response headers. So we can set those. So the content type, this is just a lookup. We have these MIME mapping types. This is like, I know where this is this thing here. So like, what is ASF? Well, that's video ASF. And what's ASX? That's video ASX. And what's jar? That's an application jar archive. So these are the possible file endings. And then these are the types. So in our case down here, this is just a fancy, like that's a dictionary string, like try to get the value path.get extension file name, and then send out the MIME type. And if we can't find the MIME type, this is a question colon. So this is basically an if. So like, if we can find this, go with it and output the MIME type. And if not, just assume it's octet string, basically assume it's binary. So like if we look up the MIME type based on the file ending, HTML should be, text/HTML, and, MP3 would be, I don't know, sound.mp3, or I don't know, whatever it is. But if we can't figure it out, just assume it's binary. I don't know, that's fine. Input.length, what's input? Well, we already, we're basically saying like, what's the length of this input stream? Okay, set that as our length. Like, we've opened up this file stream. How big is it? And then set these to like the date and last modified, which will be like, well, when's the last time that this file was written? That's what we're asking for. Or last time the file was read, whatever it is. You don't need these here. We just put these in here as an example. Now, this is where it's interesting. This creates an array of bytes. Why bytes? Because we don't know what type this file is. It could be text HTML, in which case it's just text, or it could be a movie file or a PDF file, in which case it's binary data, right? So we have to read this with bytes because it could be text or it could be binary. We don't know. We've got this int numbytes. Now this loop here just reads it. So we're saying while numbytes equal input.read into this buffer. So read data from input What's input again? Well, input is the file stream. So read from the file into this byte buffer, starting at 0 and going up to the length of the buffer. So, which is 16K. So read up to 16K of data from the file into this buffer. Now this n bytes equal whatever. This is going to return a value, which will be greater than 0 if it successfully read any bytes. If it couldn't read any bytes because we've already read all the bytes in the file, it'll return -1. So this is a clever way of like assigning this local variable and also checking if it's greater than 0. And then what do we do once we've read up to 16K? So 1024 times 16. Well, we've read it into this buffer, this byte buffer. We're going to then do context response output stream. So this response we're sending to whoever connected to us with an HT on that port 8080, we're going to then take to that output stream right from this buffer, which is starting at byte 0 and up to n bytes. What's n bytes? What's how much we just read. And if we couldn't read anything because we had read the entire file in, then this will return 0, which ends the loop. So this is a really clever way of saying, like, keep reading data into this 16K buffer and shipping it out to the client until there's no more data to read. So this works really well. For most web pages are going to be less than 16K. It'll just read the whole thing and then we'll ship it out right away and life is great. And the MIME type, the content type that we've set for the reader will have looked up the HTML extension, seen that it's text HTML, and we'll be saying like, hey, I'm sending you some bytes, but just know that it's really text. So you should read it as text because we've set the MIME type. If you're reading something big, like a big PDF file or a movie or something, you're just going to read it and write it 16K at a time. That's good because we don't know how big the biggest possible file could be. And also we don't want to like necessarily have to wait until we've read a 62 gigabyte file before we start sending it. It may be more efficient to actually send it 16K at a time until we're done, rather than to wait until on the server side, we've read all 50 megabytes and then send all 50 megabytes at once. It's more efficient to just read it 16K at a time. So that's what we're doing. We're setting the status code to HTTP OK. Believe it or not, this is just a constant. We're casting it to an int. This is going to be 200 because that's the response code success. And then when we're done, flush. Now we have this catch exception and then set the status code to internal server error, which is a 500 if something here doesn't work. And then close the output stream. So either we will have read a bunch of data and sent it out, or we had some exception, in which case we've set internal server error. But in either case, we will have, sent out, like once we close the output stream, that's it. We've either sent you the data or we couldn't send you the data and we gave you an internal server error. Totally fine either way. Now, this else, what's this attached to? Well, this is attached to if the file exists. Maybe we ask for a path like HTTP localhost / blah, 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 blah.html. Well, in that files folder, there's no blah, 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 blah.html. So we'd go through all of this and we get here and be like, hey, that file doesn't exist. What do we send then? We send a 404, right? Context response status code. This is just a constant, not found. And we're going to cast it to an int. That's going to be a 404. And we'll just sort of send that out. Now, we don't have a custom 404 page. That's the thing that we're going to want to do as one of our future things. So anyway, that's how this works. So to summarize, to make a long story short, too late. We got this HTTP listener context. We're going to get the file name, pull out that first character because we don't want the slash. If it's empty, then, well, first of all, if it's some abstract file name that we have a servlet for, in other words, if we're calling for a server-side program, find the program and run it. If we can't find a server-side program with that name, but it's null or empty, meaning, we just said localhost 8080/ and we didn't put anything else in there, then see if we can find a default index file, index.html, index.htm, default HTML, whatever it is. If we can find that, great, that's our file. So at this point, either we found this file or we haven't. Now we combine the path root directory, which is files, because remember the server's running, it needs to know to look in files because it's running from a directory up above files, and file name. If that file exists, set all the appropriate header information and read and send that data up to 16K at a time until we're done. And then set the status code to OK. If anything goes wrong, tell it internal server error, something failed on our end. Or if we can't find this file, then just send a 404 and then close the output stream either way. So we're doing that for every incoming connection. And that's what we're doing. That's basically what a web server does. Web servers can do many other things as well. This isn't like a well-written web server. That's basically what a web server does. And we've got it running here in, less than 400 lines of C# code that we can look at and kind of understand. Now, that's the background of everything that's going on. Now what we're going to do is start adding features to this. But I'm not going to do that in this video. I'm going to stop the server by typing stop. That shuts everything down. Maybe I'll show you how shutdown works, but I have to go to a meeting, and that's what we've got. Boom. Oh, that didn't stop it. Okay, hold on. I need to turn the... Hold on. Stop